Hello, welcome all. My name is Mohammad Umair. So the topic that I'm going to present now is enhancing network security with federated learning approach. So the project leader is Dr. Rifu. The team members are Mohammad Umair and Dr. Tanvi Hawk. We are from the Faculty of Engineering, Multimedia University, Sahiba. So coming up to the background, nowadays there are increasing threats of malware attacks, which is constantly evolving. Specifically, if you talk about the IoT devices, traditional approaches to detect the malware usually they struggle to keep the rapid pace of malware development. Um, Efficient techniques are needed which can do the differentiate between different malware attacks in a rapid time. Conventional machine learning, deep learning approaches methods have shown to be effective, but their effectiveness is limited due to the changing environment, dynamic, evolving nature of malware, and it also raises privacy issues when we are using the machine learning, deep learning method. So the research problem is that we in the traditional techniques, machine learning, deep learning based techniques are used to capture um, the temporal dynamics exhibited by malware behavior and privacy concern for data training on machine learning, deep learning problems. Intrusion detection is a critical aspect of ensuring the security and integrity of computer network. Conventional approaches for malware detections, they often rely on a centralized data storage and pre-processing stage, which obviously raise the concern of privacy issues. To address these challenges, federated learning emerged as a promising solution, allowing machine learning and deep learning models to be trained on a decentralized distributed data sources without sharing raw data from in a centralized network. Their such motivation is to enhance the network intrusion detection using federated learning and to develop an efficient federated learning system which can do the accurate detection even in a dynamically changing environment. So for that we use the dynamic weighted aggregation federated learning techniques. The term federated learning was firstly introduced by a research team of Google back in 2017. They published a study in the title of that study is Communication Efficient Algorithm for Deep Learning from a Decentralized Network. So for this one, we the proposed study is that we have a centralized network, and then in a centralized network, which will contain the global model architecture, which will be untrained so far. It in the global model architecture will be sent to an aggregator. These are our clients. We also have studied different clients. What would be the best number of clients that should be used uh, for the best accuracy. For that one, we have used 5, 10, and 15 different number of clients. Global model will be sent here, and then from here, obviously the data will remain on the client devices. So the data sharing for is not isn't we won't be shared anymore. Um, and the global model will be trained here locally. After then, it will be sent again to this aggregator part where we will be having our trained global model architecture, which could be used for intrusion detection. The global model architecture that we have used for study is CNN plus LSTM based model, where we have used the two convolution layer, max pool layer, and then another two, and then flat and two LSTM layers, um, dense layer, and obviously an output layer, which will be doing the classification of the malware attacks. For the dataset, we have used NB-IoT dataset, which is available on the Kaggle. Usually, this dataset was obtained from different IoT devices, such as cameras, routers, smartphones, and it contains approximately 6.5 million network flows. So, the dataset originally the dataset was distributed like this, where we each of these colors represent a different class. So obviously we have to run a different pre-processing stages where we balance the dataset, normalize the dataset, and further distribute it on the clients. Then we have used the methodology. We also, instead of dynamic weighted aggregation, we also used standard fed averaging techniques, and then done the comparison on different number of clients where we have achieved these different classification results for each of the model with respect to number of clients. The highest accuracy that we have achieved is on 10 clients, and 94.2% of accuracy it has been achieved. These are number of publications that we have done so far. For the acknowledgement, we acknowledge FRG